Welcome to this class. Today I am continuing the chapter Force and Motion of the subject Science and Technology of class 9, and this is 6th part. This chapter is divided into 10 parts and we are presenting each of the part one after another, and this is 6th part. In first part I discussed a lot about different terms related to the motion of the body. We discussed about distance, displacement, vector quantity, scalar quantity, speed, velocity, average velocity, uniform velocity, non-uniform velocity, acceleration and retardation in first part. In second part, I proved certain equations of motion. There were 4 equations. They were number 1, v equal to u plus at, number 2, s equal to u plus v by 2 into t, number 3, v square equal to u square plus 2as, number 4, s equal to ut plus half at square. These 4 equations were established in part 2. Now after that, what we did in part 3 and 4, we used this 4 equations to solve different numerical problems. And I told you how to select particular equation to solve particular numerical problem according to the given information of the numerical problem. And this way we finished up to 4th part. And 5th part we started to represent the motion of the body graphically. If a body is moving, whether it is moving with uniform velocity or it is moving with uniform acceleration or it is moving with non-uniform velocity or it is at rest, the motion of the body can be represented graphically. And there are 3 methods of representation. One is displacement time graph, another velocity time graph, another is acceleration time graph. In last class, I told you how can we represent motion of a body in displacement time graph. Today we are going to focus on velocity time graph. Okay, I want to recall a little from the previous class and I will continue with velocity time graph. Look at the screen. Graphical representation of motion. Motion can be represented by displacement time graph, which is also called ST graph. S for displacement, T for time. ST graph means displacement time graph. It is finished in previous class in part 5. Now this is part 6. Now we are starting what? Velocity time graph. This is called VT graph. V represents velocity, T represents time. This is VT graph. And another is acceleration time graph. We can represent the motion of a body with acceleration time graph also, and it is shortly called AT graph, but it is not in our book. That's why I am not going to do this. Today we are going to focus on velocity time graph. Okay, for this, what we did in previous class, what exactly is displacement time graph, I want to recall again and I will continue with velocity time graph. Okay, let's see. If someone says graph, then you must know that it has 2 segments. One is x-axis, another is y-axis, and in x-axis we will put this time, 1 second, 2 second, 3 second, 4 second, 5 second, and in y-axis we will take displacement which can be measured in meter because we are using SI system. This type of representation is called displacement time graph. This is the structure of displacement time graph, and we will obtain this type of graph for uniform velocity and this type of graph for the body at rest and this type of graph for negative velocity. We did all these in previous class. And how I define displacement time graph? This way. A graphical representation in which displacement is taken in y-axis and time is taken in x-axis to show the relation between displacement and time is called displacement time graph. It was done in previous class. Now we are continuing the same graphical representation but velocity time graph. Look at this. This vertical line represents y-axis and this horizontal line represents x-axis. And both of them are divided into equal parts, and according to our convenience we will put certain number. In y-axis we are taking 10 meter, 20 meter, 30 meter, 40 meter in displacement time graph, but here we are doing what? Velocity time graph. That's why in y-axis we are taking velocity and its unit is meter per second. 10 represents not 10 meter, 10 meter per second. 20 represents 20 meter per second velocity. Velocity is taken in y-axis and time is taken in x-axis. This way we can plot the velocity time graph. This is just the outline only. Graph is not drawn till now, but we can define velocity time graph this way. A graphical representation in which velocity is taken in y-axis and time is taken in x-axis to show the relation between velocity and time is called velocity time graph. What I have given here, look at this. This is velocity time graph. Now, I want to show some motion, some kind of motion, how it represents motion of the body. Let's say a body is moving with 20 meter per second velocity. Here it is. A body is moving with 20 meter per second velocity. At the end of first second, its velocity is 20 meter per second. At the end of second second, its velocity is again 20 meter per second. What it means? In 1 second, it covers 20 meter distance. And at the end of third second, if it covers again 20 meter distance, the velocity is same, 20 meter per second. Another, at the end of fourth second also 20 meter per second. In this way, if a body is moving, then we can join all these lines. Now, what type of graph we obtain from this information? Every second the velocity is same. Every second the body covers same distance. It means this is the case of uniform velocity. A body is said to be moving with uniform velocity if it covers equal distances in equal interval of time. We did this in previous class also, but our interest is not to define it. We have to represent this uniform velocity graphically only. A body is said to be moving with uniform velocity if it covers equal distance in equal interval of time. But velocity time graph of a body moving with this uniform velocity is a straight line parallel to x-axis, what is shown in this graph. It means if you are asked in examination or any place, what kind of velocity time graph can be obtained if a body is moving with uniform velocity, then you can say that the graph will be straight line and it is parallel to x-axis. This is about what? Uniform velocity. Okay, now next, if you want to find out the distance traveled by this body, then you can draw a vertical line from the end point, I mean to say from the end of the motion. I mean to say the final motion is at this place 5 seconds. From 5 seconds, if we plot a vertical line, then we will have this area. This area gives the distance covered by the body. And this area means what? O, A, B, C. The area of this rectangle OABC gives the distance covered by this body. How? We can write this way: velocity equal to distance by time, but distance is equal to velocity into time. And if distance is measured by measuring this area, then in place of writing B into T, we can write area of rectangle OABC, and area of rectangle means OA into OC, height into length. That's why we can write this way: area of this rectangle OABC is equal to OA into OC. And what is the value of OA? OA is 20 meter per second. In place of OA, I am writing now 20 meter per second. And OC, what is the value of OC? It is time, 5 seconds. We can write this value. And after writing this value, we can multiply and we will get 100 meter. This is our final answer. What was the question? If you have given this graph and you have to find out the distance covered by the body according to the presentation of graph, then you can use this formula, and finding the area of this rectangle, we can declare that this much is the distance covered by this body if it is moving with uniform velocity. Okay. One type of motion is represented by velocity time graph. Now, another type of motion I want to show in velocity time graph. Look at this. If a table is given to you and you have to find out what kind of motion is represented by this data. Now, we have to see the data in detail. Here time is written, velocity is written, 0 second time, velocity 0 meter per second. It means at first the body is at rest, initial velocity is 0. Yeah, and that is why it is at rest. At the end of 1 second, if its velocity becomes 10 meter per second, and at the end of second, its velocity becomes 20 meter per second. At the end of third second, 30 meter per second, and fourth second, 40 meter per second. This way it is moving. It means in every 1 second, the increment of velocity is 10 meter per second. It means the body is moving with uniform acceleration, because a body is said to be moving with uniform acceleration if its velocity changes in equal amounts in equal interval of time. So, looking at this data, we can declare that the body is moving with uniform acceleration. Now, I am going to show this graphically. Look at this is y-axis, this is x-axis. Now we are drawing what? Velocity time graph. That's why y-axis and x-axis is divided in equal parts, and in y-axis velocity is taken. We have to take velocity in such a way that the maximum velocity should be covered in y-axis. It is 50 meter per second. So, I have taken up to 70, a little more than the highest velocity. In x-axis also we have taken 1, 2, 3, 4, 5, 6 seconds, and till 5 second motion is shown, but we have to take a little more than that 5 seconds. So, up to 7 seconds is marked. This is the structure of velocity time graph. Now, I am going to fill up this value 0 meter per second. It means this point is pointed out. We have to point out this point, this one, and at the end of 1 second its velocity is 10 meter per second. What it mean? It means 10 meter distance it covers in first 1 second. That's why here it should be somewhere here, and I am going to mark that point. It is here now. This data says that the dot mark should be given to this point, and at the end of 2 seconds 20 meter per second is its velocity. It means in second its velocity is increased and gone up to 20 meter per second. That's why in second velocity we have to mark at this point here, and in third second 30 meter per second, fourth second 40 meter per second, fifth second 50 meter per second. After marking all the points as shown in the data, if we join these all, then we will get a straight line. What it mean? It means if a body is moving with uniform acceleration and if it is presented by a velocity time graph, then we will get a straight line, inclined straight line of this type of motion. Uniform acceleration is represented by velocity time graph, and what is the shape of the graph? It is inclined straight line. Okay. Now, if someone asks us question, what type of graph will get if a body is moving with uniform acceleration, if it is presented in velocity time graph, we can write this way. Velocity time graph of a body moving with uniform acceleration is an inclined straight line. It is an inclined straight line. Okay. Now, let us go to find out the distance covered by this body. I mean to say the same data I am writing here again, and the same graph I am showing again. Now, what distance will it cover exactly at the end of 5 seconds? For this, we can draw a vertical line from the last point, that is 5 seconds, and this is now right angle triangle. An area of this right angle triangle OAB, the area of this right angle triangle OAB gives the distance covered by this body. And so, the right angle triangle, area of right angle triangle can be written by half into base into height. Half is the number, base is here, it is OB, and height is BA. That is why base is OB, height is BA. It is written here. Now, what is the value of OB? OB is 5 seconds. What is the value of BA? It is what? BA, it is 50 meter per second. That is why writing this value, if we multiply and divide, we will get the answer 125 meter. This is the distance covered by that body. I mean to say, up to 5 seconds it covers 125 meter distance. Okay. Now, let us go to another type of motion. Look at this. A table is given to you and there are some values written in the table. Looking at this, what type of motion we expect about this body? Look at this, 0 second, 0 meter per second. It means at first the body is at rest, and at the end of 1 second it covers 4 meter distance. It means at the end of 1 second its velocity is 4 meter per second, 4 meter distance is covered, and at the end of 2 seconds its velocity is 10 meter per second, and at the end of 3 seconds 18 meter per second. Have you noticed this? In first 1 second the velocity is increased by 4 meter per second, but in second increment of velocity is 6 meter per second. In third second increment of velocity is here 8 meter per second. Here it is 10 meter per second. The velocity is increasing and increasing and increasing. It means the body is accelerating, but it has non-uniform acceleration. We can declare this way: a body is said to be moving with non-uniform acceleration if its velocity changes in unequal amounts in equal interval of time. I told this in part 1 while defining non-uniform acceleration. The body is moving with non-uniform acceleration. Now, how can we represent it in velocity time graph? We have to draw first y-axis and then x-axis. We can divide these axes in equal part, and then in y-axis we are taking velocity, x-axis we are taking time. Velocity is taken in meter per second according to given information, and time is taken in second. Now we have to fill up this value. 0 second is 0 meter per second. This is the point which we have to mark, and that is why I am going to mark this point. And at the end of 1 second its velocity is 4 meter per second. It means here is 10, 4 is less than its half somewhere here, and this is 4 meter per second, and 10 meter per second at the end of 2 seconds, it means here somewhere here, and it is marked, and at the end of 3rd second it is 18 meter per second, not 20, it's a little less than 20 here somewhere here, and we have to mark this. And in the same way at the end of 4th second 28 meter per second, at the end of 5th second 40 meter per second. After marking all these dot marks, if we join them, then we will get not straight line. Look at this, this line, this is not a straight line, this is a little parabolic line and it is moving upward. If it is negative non-uniform acceleration, for retardation it will go down when it goes a little up, then is still towards downward direction. Okay, if you are told to show it without the value, then you can show this way: non-uniform acceleration, velocity is taken in y-axis, time is taken in x-axis, and the graph is shown like this. Without the value we can show this. Okay. Now after this, let's go to question. This is question time. Which of the following graph represents uniform velocity? Now I am not talking about acceleration, uniform velocity. Look at the graph. Number 1, displacement time graph is shown parallel to x-axis. 2, it is inclined straight line. 3, it is parabolic line. This is inclined straight line but tilted towards y-axis. Have you noticed this? This is very interesting. I am teaching now velocity time graph, but fortunately or unfortunately displacement time graph is shown here. Intentionally I am showing this displacement time graph because velocity time graph and displacement time graph appears similar, but there is very big difference between these two. This is displacement time graph, not velocity time graph. If we are questioned about this uniform velocity, then this second graph represents uniform velocity. But the second graph wouldn't be velocity time graph for uniform velocity. If it is velocity time graph, then this straight line, inclined straight line represents acceleration, not uniform velocity. This straight line parallel to time axis represents the body is at rest. This straight line inclined towards x-axis represents uniform velocity in displacement time graph, and this parabolic line represents acceleration, positive acceleration in displacement time graph, and this straight line inclined towards y-axis represents negative velocity. Our question is uniform velocity and answer is number 2. Okay. Now let's go to another question also, because we want more question to be clear about the subject matter. That's why I am presenting more questions. Look at this. Displacement of the bodies M, N, O and P is shown in the following table. M, N, O, P. And the displacement of this body in every 1 second is shown up to 4 seconds. Which one of the options given below the table is correct according to given information? Now options are number 1, 2, 3, 4, lot of words are written. M is uniform velocity, N is variable velocity, O is non-uniform velocity, non-uniform acceleration. In the same way, so many things are written. And now it is a little confusing. That's why. Why should we go through this confusion? What type of motion M represents? We can see from this data. Now look at this. M, it covers 30 meter distance in first second, 30 meter again in second, third second also 30 meter, fourth second also 30 meter. It means it covers equal distances in equal interval of time. The body is moving with uniform velocity. That's why we have to select the option where is uniform velocity written for M. First M, uniform velocity, M, uniform velocity, M, low. All of them are written uniform velocity. That's why all the options may be correct. We have to go through N, O, P also. Now N, in case of object N, at the end of 1 second it covers 6 meter, at the end of second 12 meter, and at the end of third second 18 and fourth second 24. What it mean? At the end of 1 second its velocity is 6 meter per second, at the end of second 12 meter per second. Increment of velocity is 6 meter per second here, and 12 to 18 third second if it covers 18 meter, then 6 meter per second is the increment. It means every second the increment of velocity is same. The body has uniform acceleration. A body is said to be moving with uniform acceleration if its velocity increases in equal amounts in equal interval of time. That's why object N is moving with uniform acceleration. Now we have to see second option, I mean to say first, second, third, fourth, all the options. Second point, N is variable velocity. No, this is wrong, not correct. N is uniform acceleration. Yes, it is okay. Now look at third also, uniform speed. This is not correct. And N has acceleration. This is also partially correct. Acceleration may be uniform or non-uniform. That's why we can go through number 2 and 4. But we have to see the motion of object O and P also, and then we will declare among 2 and 4 which one is correct, because 1 and 3 is incorrect, it is already decided. Okay, object O, at the end of 1 second 20 meter distance is covered, at the end of second second, in second second only 30 meter distance, in third second only 60 meter and 70 meter. It means at the end of 1 second velocity 20 meter per second, here 30 meter per second, here 60 meter per second, here 70 meter per second. It means the change of velocity in equal interval of time is not equal. It means the body is moving with non-uniform acceleration. A body is said to be moving with non-uniform acceleration if its velocity changes in unequal amounts in equal interval of time. Same thing is happening here. That's why object O has non-uniform acceleration. Now we have to go through this. O, non-uniform acceleration, seems to be correct. Now number 4, O, uniform velocity. No, this is incorrect. That's why till now option 2 exists, but other they do not exist. Now let's take the last also, object P, 13 meter, 26 meter, 39 meter and 52 meter. It means the increment of velocity here at the end of 1 second if 13 meter per second, then at the end of second 26 meter per second, 39 meter per second. It means increment in velocity is 13 meter per second in every 1 second. What it means? The body is moving with uniform acceleration. The difference of velocity in every 1 second is 13 meter per second. That's why again uniform acceleration. That's why the option 2 has got what? Uniform acceleration again. Look at this, uniform acceleration. So out of these 4 options, only second option is correct, but 1, 2 and 4 are not correct. This way we can declare looking at the table. Okay, this part also finished. I think you are feeling a little difficult to understand all this, but looking at this table, we have to go through uniform velocity also, non-uniform velocity also, uniform acceleration also, non-uniform acceleration also. This question gives us clear idea about all these motions. That's why this is very important, I think, and I am presenting this question. Now next, this is another question. Look at this. Which segment of the following graph represents maximum acceleration, uniform velocity and minimum retardation respectively? Which segment? No, it's not necessary to say respectively. We have to answer this segment. Which segment represents maximum acceleration? Which represents uniform velocity? Which represents minimum retardation? Okay, there are some options: A, B, C, D and D, E respectively, D, E, F and F, G respectively. These are the options. Instead of going through these options, we have to go through the question. Look at this, maximum acceleration. Now there are many segments, OA, AB, BC, CD, etc., etc. Among these different sections, where is maximum acceleration represented? Maximum acceleration. First you have to know that velocity time graph of a body accelerating is a straight line, inclined straight line. If negative, the inclination is towards y-axis. If positive, inclination is towards x-axis. Now if not told positive and negative, we have to take it as positive. Maximum acceleration. Here we have acceleration from O to A. This segment represents acceleration. This also represents acceleration. This also represents acceleration. All these 3 segments represents acceleration. Now question is maximum acceleration. Which one represents maximum acceleration? I want to show with angle. Look at this angle. OA makes this much angle with the time axis, I mean to say x-axis, and AB makes this much angle, this angle with time axis, but BC represents this much, this angle. It means the angle made by this this segment is less, this segment is maximum, this segment is more than this but not maximum. That's why if you have to search for maximum acceleration, then you have to see that the angle made by that segment should be very high with x-axis, and this is AB. AB makes very high angle with x-axis than others, so AB represents maximum acceleration. Now search AB in the option. In number A there is AB, in number C there is AB. That's why these two exist for us. B and D are not correct. Now we will go through A and C. We have to check it out again. Uniform velocity. Now which part represents uniform velocity? CD represents uniform velocity. EF also represents uniform velocity, because we know that velocity time graph will be a straight line parallel to x-axis represents uniform velocity, and that's why CD and EF represents uniform velocity. We had two options, A and C. In A, CD is written but EF is not written, but in C, CD and EF both are written. That's why this is more correct. But let's take another option also. What is given? Minimum retardation. Which one represents minimum retardation? DE represents retardation and FG also represents retardation, because velocity time graph will be straight line, inclined straight line, but inclined towards y-axis for a body moving with retardation. So DE and FG, but here minimum retardation is told. That's why we have to check the angle. Look at the angle. This angle is, now I am comparing with this angle. Which angle is more? This is more, but here we have to say, we have to select minimum retardation. This is the minimum retardation. This is more than this. So FG represents minimum retardation. Where is it? In A? No, it is D. In C? Yes, it is FG. Every point is correct of this C, of this option C. So we have to select C. This is the correct answer. Okay, now I think I told you everything related to velocity time graph for the science and technology of class 9, subject science and technology of class 9. Now you have a little idea how can we plot velocity time graph, how can we show different type of motion by using velocity time graph, and we can compare velocity time graph of different type of motion also. Okay, this is the end of graphical representation of velocity time graph. Okay, this much for today. We will meet in another class. Thank you.